the number of broadcast station. Number of broadcast, AM broadcast station. And here hint is given that AM broadcast station is operating in 100 kilohertz. That means this is the total bandwidth is provided. And in which, in that bandwidth, the highest modulating frequency is available as 5 kilohertz. As it was written, in the highest frequency modulating a carrier. Means it is not a carrier he is saying, it is a modulating signal whose frequency is 5 kilohertz is given. Okay, this carrier is only identifying that modulation is taken place. But here he is asking about the modulating signal. Among the modulating signal, the maximum highest frequency is 5 kilohertz, and this is the total bandwidth. So, how many number of broadcast system we are going to identify? Let's see. So, here I will write solution. This indicates that, for example, this is the total bandwidth, okay, which is 100 kilohertz. This 100 kilohertz bandwidth is available to you, okay. In this, the higher frequency component, n number of modulating signals are available or modulated signals are available, in which the maximum frequency, that means here I will say the F max, F max is 5 kilohertz. This is the F max, this is the frequency having certain amplitude, and this is the bandwidth of 100 kilohertz. This is the bandwidth, and the modulating signal is maximum frequency is this. Means among the modulating signal, the highest frequency is this 5 kilohertz. So when I modulated it, then it will transmitted in this 100 kilohertz. Okay, and how many number of broadcast stations is asking? So how many number of broadcast stations means the number of broadcast station is equals to the total bandwidth available by the bandwidth of a modulated signal. Bandwidth of a modulated signal. So this is the ratio. Now, how to calculate this bandwidth of a modulated signal? This modulated signal is one component I am saying. Okay, this modulated signal is only one, because only one frequency component is given, means the bandwidth you can identify for that modulating signal. So what I will write, total bandwidth is available is 100 kilohertz, 100 into 10 to the power 3 hertz, and the bandwidth available in the modulating signal. So this is the maximum frequency available in the modulating signal. So for this modulating signal, what is the bandwidth? The bandwidth is twice of f max. Done. So it is 100 into 10 to the power 3 divided by 2. What is the f max? It is 5 kilohertz. 10 to the power 3. This get cancelled out. Resultant is 10. So number of broadcast station is 10. So this is my answer. So 10 is the number of broadcast stations. How we have identified this 10? By simply dividing the total bandwidth divided by the one bandwidth available for the modulated signal corresponding to this modulating frequency 5 kilohertz. Okay, so this is the small numerical to understand if a particular band is given, and with the help of that particular band, if a modulating signal is available, how many number of broadcast system can be identified. So this is the small example. Okay, now we will go for one more question. 1 minute. So one more question we'll discuss. So here the question is total power content of an AM signal is 100 watt. Okay, here we need to determine the power transmitted at carrier frequency and at each of the side band. Okay, each of the side bands when the percentage of modulation is 100. 1 minute. Is bit A 100, bit B 50 and bit C 25. So this is our question. Okay. Now related to this question, what are the given data? Here it is given the total power is transmitted. Now in the last class I have told the transmitted power is nothing but the AM power. So indirectly it is written as AM signal. So here I will write given data. Okay. In given data what I will write? The transmitted power. Transmitted power is same as AM power. How much it is? 100 watt is given. Okay. Now what we need to determine? We need to determine power transmitted at carrier frequency. That means he is asking about the carrier power. Okay. So that means PC we have to determine. Done. And each of the sideband power also they require. Each of the sideband power means P LSB is equals to P USB. Okay. So these are the things we need to identify. And what are the other hints are given for different case? For different case, our percentage of modulation capital M is given for 100. We have to calculate for this carrier and sideband with respect to 100, with respect to 50 and with respect to 25. Okay, step by step we will see how to calculate. Now as we know that transmitted power is equals to carrier power plus Ma square divided by, this is the general equation or general relation between transmitted power, carrier power and modulation index. So how to determine this modulation index? So for bit A means M is equals to 100 I am calculating. Okay. If percentage is 100, that means MA is 1. Okay. If MA is 1, that means here I will see PC 1 plus 1 by 2, or here I can write 3 by 2 times of PC. Done. For MA is equals to 1. We need to calculate that PC. So PC is equals to PT 2 by 3. Take this component to this side. So PT into 2 by 3. So PT is 100 into 2 divided by 3. So it is 200 divided by 3. So this is my carrier power. In calculator you can calculate. I don't have a calculator. If I will divide it, decimal it will come near about. If it is 20 means 66 point something it will come. Okay. So I am leaving this value in a fraction mode only. You can calculate it and you can find out the decimal value. So it is PC is equals to 200 by 3. So PC is equals to 200 divided by 3 watt, because the unit of power is watt, WAT. Now I need to calculate the sideband power. How I will calculate? As we know, transmitted power is equals to carrier power plus sideband power. Done. So PT is given, PC we have calculated. So sideband power PSB is equals to PT minus PC. So it is 100 minus 200 by 3. Again it will come 100 by 3 watt. 100 by 3 watt means 33.332. You can consider this one as a 66.66 watt, and this one you can consider 33.33 watt. Done. So it is the sideband power. But individual sideband is how much? Individual sideband we can calculate with respect to individual sideband for MA. M is equals to 100% we are using, where MA is equals to 1. So LSB is equals to USB is equals to sideband power divided by 2, because equal power is distributed. So if it is 33.33 divided by 2, so it will come around 15 or 16 point something it will come. So it is 116.66 watt it will come. So this is the sideband power. Sideband power is 33.33 watt, but individual LSB and upper sideband power, simply you have to divide by 2, you will get 66.66 watt, 16.66 watt. So this is the case for modulation index if it is MA is equals to 1. Similarly, we can determine for 50, we can determine for 25. Okay. So for 50 I will calculate, for 25 you should try. Okay. So one by one I will solve once again. It is not like that only I will solve and you will sit and listen. So for this bit B, if your percentage of modulation is 50, that means MA is equals to 0.5. Okay. So that means my carrier power is equals to transmitted power whole divided by MA square by 2. Like this also I can write. In place of MA, substitute this. So here it is 1 by 2. So power transmitted is 100 watt. 1 plus MA square means 1 by 4. It will become as 1 by 8. So it is 8 by 7. 8 by 9. 8 by 9 into 100. So it is 800 divided by 9 watt. So this will be my carrier power. Similarly, sideband power is equals to transmitted power minus carrier. So it is 100 minus 800 divided by 9. You will get 100 by 9 watt. So this is the side band. Now LSB and USB just divided by 2 of sideband power. So sideband power divided by 2. So it will become 50 by 9 watt. Done. So like this you have to calculate for 25% of degree modulation. That means 25 means modulation index will become 0.25. Done. So same procedure, only your MA is going to change, and the rest of the thing according to the MA, the sideband power you can determine, carrier power you can determine, as well as you can determine the lower sideband power as well as upper sideband power. Okay. So we will proceed for one more question. So one more question. So determine power content. बाद में आप मैं थोड़ा इसको खत्म करूँ. Power content of each of the sidebands, and carrier. लव क्या है?
प्रिंसिपल सर साइन करना बोला है, तो मतलब ये नहीं है ना. अब मैं इसी का स्टूडेंट हूँ, तो प्रॉक्टर मेरा है IAS में, वो भी एब्सेंट.
उस दिन साइन कराया था ना.
हाँ, तो वो लेटर में लिखा हुआ था, मैं लिखा था फिर चेंज ऑफ ब्रांच, तो सर बोले कि उसको हटा के फिर से लिखो लेटर. रिकॉर्डिंग
बंद कर दो उसे. Carrier of an AM, carrier of an AM signal that has a percentage of modulation, of 85%. Done. And contain 1200 watt of total power. Done. So according to this question, sorry for the interruption. Here we need to calculate the power content in the each sideband. That means PLSB and PUSB, as well as the power content in the carrier of an AM modulated signal if the modulation index is 85 and the transmitted power is 1200 watts. It is a simple one. How we can calculate? What are the given data? Transmitted power is 1200 watt. Okay. Modulation index is 0.85. Directly I am writing because here modulation percentage is 85% is given. So modulation index is 0.85. Now we had a relation PC is equals to PT divided by MS square by 2. Then in place of PT substitute 1200. In place of MS square substitute 0.85 whole square divided by 2. So it is 2400 divided by 2 plus 0.85 whole square. Now with the help of calculator, people can calculate and determine what is the carrier power. So carrier power will come around 881.5 watt. So carrier power is equals to 881.5 watt. Okay. Now once carrier is known, sideband power again. So sideband power is how much? PSB is equals to PT minus PC. PT is 1200 watt minus 881.5. So how much it will? 0.5, 9, this is 8, 9, this is 1, 11, this is 3. So 380 watt is the sideband power. Then PLSB is equals to PUSB is equals to 380.5 divided by 2. How much it will be? It is 1, then it is 5, 9.25, this much watt. So this is the sideband power available with respect to lower sideband as well as with respect to upper sideband. And here the modulation index is 0.85, contains this much transmitted power. That means modulated signal power is 1200. So like these questions are available in your textbook. Go through these questions, solve it. If you have any sort of doubt, then note it down and send those questions to me, so that in next class I will discuss those questions so that everybody can aware of it. Okay. So we will proceed for one more question. So one more question we will take and then we will wind up this session. So the question is, a given AM broadcast, station transmit a total power of 50 kilowatt. 50 kilowatt. When the carrier is modulated by a sinusoid signal with modulation index of 0.707. Okay, now you need to calculate with A carrier power, that is called PC, bit B efficiency of transmission, and bit C is the peak amplitude, of carrier. Okay, so this is a question in which we have to determine these all factors. So what are the things are given? First, it is an AM broadcast, okay, in which the station is transmitting the AM signal at a rate of, means at a power of 50 kilowatt. So that means PT is given as PAM, which is equals to 50 kilowatt. Done. When the carrier is modulated by a sinusoid modulation, means when the carrier is modulated with a sinusoid signal, and that sinusoid signal is our modulating signal, with a modulation index MA is equals to 0.707. 0.707 means it is 1 by root 2, okay, or directly you can write 0.707. So here we need to calculate PC, okay, we need to calculate PC. So how to calculate PC? PC is equals to PT divided by 1 plus MS square by 2. This is the relation what we have got from the derivation. So PT is 50 kilowatt divided by 1 plus MS square means 1 by root 2 whole square divided by 2. If you solve this, how much you will get? 1 by root 2 whole square is 2. So 1 by 2 and this 2 will become 4. So we will get 4 divided by 5 into 50 kilowatt. So that means resultant is 40 kilowatt. So that means the carrier power is 40 kilowatt. Similarly, we can find out sideband power, which is equals to transmitted power minus carrier, that is 50 minus 40, which is equals to 10 kilowatt. As well as you can calculate P LSB is equals to P USB is equals to P SB divided by 2. So that means it is 10 divided by 2 means 5 kilowatt. So this is the LSB and USB power content. But what are the other factors we need to identify? The other factor is the efficiency of a transmission, and then peak amplitude of the carrier. So how we will determine efficiency of a transmission? That also we had a relation with modulation index. Okay, that we will see. As we know, efficiency of transmission is sideband power divided by transmitted power into 100. Okay. Now what is sideband power? What we have written? It is MS square AC square divided by 4. Transmitted power consists of carrier power and sideband power. So carrier power is AC square by 2R. Then sideband power is MS square AC square by 4R. Now if I will solve this, I will get MS square divided by 2 plus MS square. Done. Simple relationship. Now here MA is given as 1 by root 2. So here MA is given as 1 by root 2. For that we have to calculate the efficiency. So it is 1 by root 2 whole square divided by 2 plus 1 by root 2 whole square. So it is 1 by 2, 2 plus 1 by 2. Because 1 by root 2 whole square means it is 1 by 2. So if I will solve this, I will get, so these 2 and these 2 will be cancelled out. So I will get 1 divided by 5. So 1 by 5 into 100 will get 20% of efficiency. If my modulation index is 1 by root 2, my efficiency is going to be 20%, because this 1 by 2 and this 1 by 2, so this will become as a 4, then 5 divided by 2, so this 2 will be cancelled out. 1 by 5 means into 100, that is 20%. So modulation index is done, efficiency is also done. Only we need to calculate the peak amplitude of the carrier. How we are going to calculate? Let's see. In previous class, I have drawn a diagram like this. This is my source VAM plus minus, here it is IAM, and this is the dipoles are available. Current will move in this direction, current will enter in this direction, EM waves are generated. Done. Here one thing is missing, peak amplitude carrier and the antenna impedance, that is R, is equals to 50. Here you can write Z is equals to 50 J0 ohm. This is the hint will be given. I have not given, but hint will be given in your question. So Z is equals to 50 plus J10. This Z is equals to 50 plus J10 means it is an impedance available in this antenna. Then only the potential drop will be there. Okay. So if the impedance is this, so that means I can say R is equals to 50 ohm from this, because Z is equals to R plus JX, X component is 0, so R is equals to 50. Okay. Now as we know, we need to calculate AC. How to calculate AC now? As we know, carrier power is equals to AC square divided by 2R. Simple relation. From this you can determine AC. So AC is equals to root over of 2R into PC. Okay. So 2 into R means it is 50, and carrier power how much we have identified? Carrier power how much we have identified in the previous one. So carrier power we have identified as 40 kilowatt. Okay. So this is the carrier. So that carrier power substitute here 10 into 3. Now if you solve this, how much will you get? 0, 0 and this 10 to the power 5. Now it is 10 into 4, 40. So 4 into plus 1 means it will become as 6, 10 to the power 6. So 2 into 10 to the power 3 volt. Or you can say the carrier amplitude is 2 kilovolt. So like these questions will come in your exam, which will have a relationship with respect to AM, carrier power, transmitted power, and modulation index, efficiency. Here we have considered in terms of power. In questions may come in terms of current. Don't confuse, in place of power and need to substitute current. And that relation also we have discussed, that modulation index is related with current with respect to the power. So modulation index, root over of twice, this is PT divided by PC minus 1. In place of PT you put IT square, in place of PC we need to substitute IC square. So it is IT, it is IC whole square minus 1. In this sort of thing also we can identify the modulation index if it is written given in terms of current. Here it is given in terms of power, here it is given in terms of current. Okay. So today we will wind up in this. Next class few more questions we will discuss, as well as the other modulation scheme also we will discuss. But in next class few more questions we will discuss, around 4 to 5, or I will try to solve around 7 to 8 questions. Okay. So thank you all.